Okay, so my name is Mirko Kovac. I'm from Imperial College, and it is my real pleasure to speak here today. Also, thank you for staying so long. I think I'm the last talk, so which divides us in front of the upper row, so there's a couple of more minutes. So today I'm going to talk about drones for humanity. Now, I deliberately chose the word drones over flying robots or unmanned aerial vehicles because drones are very often not connected to the word humanity. So in the media, that's really prevalent applications that are questionable. There's a debate around that. So in this talk, I will show you how drones can be used in smart cities, in future cities, how they can improve our quality of life, and how they can help us to help us all, basically, to improve our quality of life. Now, before I do that, let me start with a quick movie, just to see something. No, that's not a robot, as you might think. But it is the beginning of the inspiration to build flying machines. So the dream of flying started with looking at the beauty of animals, at birds. So people started to wanting to build machines that can fly as well. People wanted to fly. So the first flying robots were inspired by biology and the concept. Now, in the meantime, obviously, at the early days, this wasn't possible. So the early robots were pigeons, let's say pigeon post, right? The first deliveries with flying vehicles that were for the purpose of human transport. Other applications include also pigeon photography. So you see this pigeon with these heavy cameras. I think it was in the 40s where they used that, so the poor pigeons. But it's basically the similar motivation of using flying vehicles to do things that can help us. Now today, 2014, the market looks like that. So we have drones already on the market. They can be deployed by hand. They can then fly, take pictures. They are used for cinema, like for taking pictures or aerial photography, for mapping of the environment, and traffic control, smart agriculture. So there's a lot of applications that are already now addressed and solved to some extent with flying vehicles. So they can provide a very detailed map of the environment, for example. Other applications include, as I'm sure you've seen, for example, Amazon or DHL or Google also. They want to do drone delivery, so delivering objects, delivering pizza with drones, right? So that's the near future. I think very soon we'll get there so that this will be possible. And actually, at the moment already, we can buy drones at a few £100 that can be flown with an iPad. So everyone here can have such a drone. Is there anyone who actually owns one like that?
£25.
Okay. Exactly. So they get really cheap. Really, it goes into the consumer market now. Other applications are, for example, Facebook uses drones to provide internet coverage in inaccessible areas. Or in London, the Yo Sushi flying burger. So they did some drone burger delivery in the restaurant. There is a lot of different applications. And to show you some of the robots, so we brought one here. So I have one robot here. Actually, it's this. That's my robotic pet. So that's the advantage if you're at the university, you can buy all these pets. So I have a leash also for health and safety, right? Being in a law firm doesn't help. so be very careful. Okay. Now we can quickly, just to get an idea how this behaves. I'm sure you've seen it already, maybe. You take off. And then you can go for a walk with that, you can enjoy your leisure time. It behaves very well usually. Okay, so then when you get thirsty, you can also have this. I can bring the beer, right? As I mentioned, or some water, right? You can salt roll. Liver. But as you see, you can hover, so it hit me, it wasn't too bad. Okay, so just to get an idea, so these platforms you can buy, this one is an expensive one, but it's always basically the same. So they can fly maybe 10, 15 minutes. They can carry, something like this, 50 grams, 100 grams. The biggest ones can carry about 20 kilograms. And so the big challenge is really to do drone delivery with this, because they're really not there yet. On the stability, so you see the hovering wasn't very precise. And so there are a lot of challenges that need to be addressed. But we are partially there. Now, applications include, for example, or where this application can really be transformative is drone delivery in developing countries, such as here in Africa, where people are looking at these flying donkeys. So basically, instead of going into the infrastructure to create roads, going directly into drone networks. So the same happened with wireless technology, where many cities adopted wireless technology directly without going into wired systems. So the same is happening now with drone delivery in Africa. Now the main challenge here is how to fly inside of the cities, how to land inside of cities, how to fly safely. Right, although this is solved here to fly along GPS coordinates, it's still the technology needs to be developed to fly safely around humans. So to illustrate that, we do some of that research. We have here a PhD student of our lab who is testing the drones in Honduras in the rainforest. So we do use those drones for parameter detection, for ecological research. And as you see, so it can fly, but then as soon as it hits an obstacle or it comes close to a tree, it crashes, and it's not very healthy. So that's why he wears a helmet. That's one of the reasons. So the commercial platforms are not there yet to actually do navigations in complex terrains. Another challenge or another application is this aerial photography, but there is the challenge that some animals get envious, let's say, right? So this is because they get really good in aerial photography. Yes. But at least you get a picture from there. Okay, so other challenges include flying inside of forests, flying in cities. So how do you fly safely close to humans? Who takes the liability if it crashes into someone? How do you manage it? How do you manage it if somebody wants to steal the drone? So the pizza delivery drone comes and doesn't come back. So how do you manage that? Another application, another area of challenging area is operation in water, in air, or in coastal regions. So how do you fly in these areas? Or if you want to fly close to an industrial, like an oil platform, close to facilities, close to pipe work, pipeline inspection, how do you fly there? There are big areas that are now being addressed by the community to solve and fly in these environments. So the vision in my lab, so what we do is drones for humanity, and we look at how they can be embedded in future smart cities to help us to do different things. Now, one area we look at is drone delivery, so using swarm control to actually deliver drones very effectively. On the other side, drones for environmental monitoring, so ecological monitoring to detect pollution in the environment, or smart agriculture as well. Other areas include drones for water health, so using drones that can provide water samples, which is very important in future, so water is the upcoming resource, so we have to be careful with that, and this can help in monitoring this. And also drones for inspection and repair. So you can imagine that in this city, in this future scenario, I mean, obviously it's an artistic vision, but I believe very soon we will be there, and we will have drones that will serve us, that will live in synergy with us. And they can be used, they will be living on those buildings and inspect and repair parts of the building autonomously without any human interaction. Okay, so I will walk you now quickly to some examples that we have done in these areas to just to see the approaches that we take there. Now, the first is smart agriculture. Now, if you have a huge farm field, what obviously is very important is to manage the water content, so how much water to put on, how much pesticides and fertilizer, and for that it's important to monitor and sample the farm field, especially for very high quality crops like berries, for example, where it makes a big difference of what you put on it, how much fertilizer you put on it. So there you can imagine to have drones that will go and sample the environment, measure the pH levels or the water content, and then allow us to smartly design how much of these things are put on this farm field. Now, when you want to do that, obviously you cannot move very well on this rough terrain, and there we can look at the animal kingdom again and see how animals move effectively in these environments. And one animal that does that very effectively is the grasshopper. As I'm sure you have seen, if you walk in the summer through the grass field, they move very effectively. Now, if they wouldn't be able to jump, they would not be able to move in this environment. And for that, we looked into these animals, we extracted the key design principles, how to build this type of system, and we built a jumping robot that is very similar to that. So it looks completely different, but it used the same design principles. So it charges an elastic element, it then releases this very quickly and can jump up like this very high. In fact, it can jump up to 1.4 meters, which is about the same relative jumping performance as a grasshopper has. So it's really, we are able to achieve this performance because of the biological inspiration that we are able to take from the animal. So just one slide on the methodology of how we do that. What is important is that we take the inspiration, so we are naturally inspired by the system. We then want to design it for a certain purpose, and we optimize it for certain functionalities. We then take the abstracted principles, such as 4-bar mechanism or energy storage. We build this into the mechanical design, fabricate the prototype, which uses the same principles, but looks very different. So this is the way how I believe bio-inspired or biology can inspire us as engineers to build high-performance systems. Now, the same happens in finance, happens in computing, where also we can take inspiration from algorithms in nature to actually build better engineering systems. Another example is the gliding squirrel, as you see here, or gliding lizards. And what they do is they do jump gliding. So they jump and glide to move in forests. And we also explore that and build those jumping drones that would live in the forest, move in swarms, and collect information about the environment. So if you imagine, instead of having one big robot which is expensive and can break down, so as mentioned before by Mark, the Curiosity rover on Mars, it took very nice pictures, right? It had wheels, but correct me if I'm wrong, but I think he got stuck after some time, so he didn't come back and he couldn't move anymore. And I think this really shows that wheels might not be the best way how to move on rough terrain. So instead of having those wheels, we could imagine having swarms of thousands of those robots that would actually be energy self-sufficient and move around and like this provide information about the environment. Okay, so another area that we work on is drones for water health. And so these would be drones that can dive into water, take underwater video footage, for example, inspect underwater turbines, or sample the environment to provide us with water quality readings. Now there's a huge market in that, there's huge opportunities. And the way how we do that is that we take inspiration from bomb diving animals like these gannets here. So if you live in Scotland, you might have seen those. And what they do is they bomb dive from about 50 meters height into the water. They fold their wings so they wouldn't break. Then they dive underwater, they catch fish, obviously they're interested in fish. But using similar principles also from flying fish or flying squid or those diving birds, we can build the next generation of flying robots that can not only fly, but can also move underwater. Now these robots, we call them aquatic microair vehicles or aquamavs. And here just one example of in an oil spill scenario. For example, you have an oil spill, you want to react quickly to the situation. And then you could have this swarm of these aquamavs on a rescue vessel that will go there in swarms, sample the environment. And like this provide much faster reaction than with manned vessel. Now currently people are going there manually to take the sample. Takes a long time, is dangerous, is very dangerous, it's very expensive. So having this type of robots really can transform how oil platforms are run, how oil tankers are run, and other applications as well, such as, for example, also for flooding situations. You want to really rescue the people very quickly, so also there you can have those robots that can sample and provide information about the environment. Okay, so the first prototype looks like that. It's about handheld, and as you can imagine, it's very difficult to get out of the water and then retake flight. So we work on all these different challenges, and the first prototype that shows that we actually can do the transition is this. So it jumps off from here. And using a water jet propulsion similar to flying squids, we can actually jump up to a distance of about 100 times its size. So it can jump very, very far with this very high power density propulsion system that can enable those new platforms. Now, the last topic that I want to talk about is drones for inspection and repair. And here you can imagine that these drones will be living on those buildings. And here again, we look into nature and we look at how animals build structures. So one example is spiders. And looking at that, it's simply, on one side, simply amazing how they can do that, how they can build structures between trees, between basically an unknown, completely unknown environment. So they don't know anything about the environment, and they're able then to build a platform that they can live on. So it's basically a house, it's a platform. It's also a sensing unit. So they sit in the middle of the spider nest, and depending on the vibration of the web, they can hear what happens in the environment. So we're looking at different similar technologies of using robots that would build their own nests and live in the environment to help us in repair structures. So another examples are those birds. So they're the editable nest swiftlets, or swifts. And you might know them if you know bird nest soups. I don't know, you have tried bird nest soups. So it's a delicacy, and it's made from the saliva of those birds. And in fact, these nests are made of the saliva, and they do this by additively depositing their saliva, which hardens, and like this they build up the nest. So it's basically 3D printing that they invented first. So we should give them some credit for that. But it is actually 3D printing. So the next step is then to combine it with amorphous materials and build larger nests. Now, taking inspiration from those animals, we build a 3D printing drone that uses expanding foam that it would use to seal structures or to build up material and like these 3D print structures. And so to have an example of a current prototype, we have here the platform, here the nozzle, and you see it's actually quite precise. And the flight control to actually 3D print and like this either seal gaps. So for example, you have an oil pipeline that has a crack, so it would fly and 3D print to heal the structure. So it can be used for many very useful applications, but also just to put our lab logo, in different buildings, like this promote. Anyway, the next structure that we're working on in parallel also is 3D scanning drones that have cameras using stereo vision or scanning laser scanners. Like this, they would work in swarms together with the 3D printers to detect the damage and then 3D print to repair it, like this, be completely self-sufficient. So in the future, I believe industrial power plants or any kind of facilities will be very little supervised by humans and will be mainly inhabited by robots. And I think this is a step-changing technology. Once this happens, when we are able to have developed those robots that can actually be completely autonomous and live there and help us to run our world, basically. Okay, so a few words about Imperial College. I'm not sure if you're familiar with Imperial College. So it's located in central London. So this is Hyde Park. This is Royal Albert Hall. That's Imperial College here. The Science Museum is here, this building here. And the 3D printing drone, by the way, is now located in the Science Museum. So if you want to see it, you can go. It's in the antenna gallery on the ground floor. So you'll see 3D print next to the 3D printing gallery. And so a few things. So we have 18 groups at Imperial College that work in robotics, which makes us one of the biggest centers in Europe in robotics, different aspects of robotics. So the Aerial Robotics Lab is located in this building. We have a rapid prototyping center, so we really benefit from 3D printing, from all the great talks we have heard this morning. So this really enables our design cycles, so we're actually able to develop those robots because of these 3D printing capabilities. Without that, it would be extremely difficult. We have a new flight arena. We just got funding to build a new building where we have a flight arena. We can test those robots and develop new systems. Of course, the wind-water tunnels help us to develop it all. We also do outdoor testing in Hyde Park, so if you go to Hyde Park and see some flying drones, it might be ours, so don't be too scared. It should work. We also use that Imperial West. There's a new campus where we have more outdoor testing facilities. Now, one thing that I wanted to build on the presentations this morning is, and something that I'm very passionate about as well, is the integrated teaching and research labs where we actually build 3D print robots, we iteratively design them, and together with teaching labs, we train the next generation of engineers that will be able to work on unmanned aerial systems and develop this space of robotics. So that's just one example. So this happens at Imperial College, but similar initiatives happen also at other universities in the US, in the UK. So a lot of investment is going now into that, and it will really enable us to have a lot of civil applications, a lot of drones that can help humanity for different applications. So in fact, it's not really humanity, it's also for forests, it's also for animals, for lakes, for renewable energy, for water health, for medicine, right, delivery. So there are many applications where these drones will help us. Thank you very much.